What Autodesk is doing is bringing together all of its manufacturing software into one suite for additive and subtractive. That way people can have a continuous workflow from design, simulation, optimization, print preparation, and then post-production. So what we're doing with Netfabb is bring together all the tools you need to get a successful 3D print, no matter what the technology, what the hardware you're using. So we have, you can bring in your design, you can make sure it's watertight, you can optimize it with ladder structures that came from within. You can then simulate the build using some simulation tools we have to see whether the build's going to be successful. We can look at distortion and correct for that, send it to the printer, and then afterwards you can do the machining you need to face off that material to make it the final part. We're entering a time in additive manufacturing where people are working together better. In the past there's been silos, these monopolies based on machine material combinations, but now we're opening up with our software and bringing in open partners in hardware and materials so we can work together as a team to grow the industry better, to grow the ecosystem. It's a very interesting time for the additive industry. We're seeing big newcomers come in, as well as startups who are coming in from below, and it's making for a really diverse ecosystem. So we're not just having these major players hitting really heavy, we're having these small companies come in at the same time and introduce technologies that are in a very fast pace. So the combination of big companies and small companies all bringing in new technology is really making things grow quickly in a diverse ecosystem. One thing that's important to ensure we can have continuous chain between design and manufacture is feedback from the machines. Because as it stands now, we're doing the best we can with simulation and we send it to the machine, but then afterwards, we don't know if it's succeeded, if there's failure, if there's been an issue with the material or the machine. So what we need is in situ monitoring to come back into the design tools so we can then optimize and make things better and continue the flow. I think of it as similar to in photography. Like when we had analog cameras, you'd take a photograph and then a week later you'd see a print and you go, oh, this was a terrible shot. We're in the same place now with manufacturing. But once people could start using digital cameras, they had instant feedback. They saw they had to adjust the lighting, adjust the composition, adjust your aperture, and you could become a quick photographer. We see the same thing needs to happen in design, but to do that we need feedback from the machine. Autodesk is looking at the cloud for the power of multiple processing. So we know that we can only do so much on your laptop or on your computer at your workstation. But by taking the power of the cloud, you can do multi-processing simultaneously to get much more complex equations solved quicker. We're especially looking to do this with our simulation tools, which otherwise could take weeks to process. By using the cloud, we can do it much, much faster.